Alright guys, so this video is going to focus on how do we solve equations with rational exponents. So essentially, if your equations have exponents that are fractions in them, how are you going to solve those? So if we can see here, example A and example B both have fractional exponents right over here. So we have x minus 3 raised to the 3 halves, and then we have this trinomial raised to the 3/4. So the first step that you want to do when working with these kind of problems is you want to get your term that has your fractional exponent completely by itself on one side of the equation. So you can see example A is already done for us. So the x minus 3 to the 3 halves is by itself on the left-hand side of the equation. That's the way that we want it. Example B is almost there. It has this minus 7 hanging out. So the first thing we would do for example B is move that 7 over to the other side. So A is already in the proper form for us. So we can go ahead with solving that equation. So what you need to do after that, so the second step after that term is isolated, is you're going to raise both sides of the equation by the reciprocal of that fraction. So we have the fraction of 3 halves. The reciprocal of 3 halves is 2/3. Remember the reciprocal, you just flip the fraction, and that's your reciprocal. And the reason why we flip the fraction is because, so on the left-hand side and the right-hand side, if we raise both of these to the 2/3 power, let me show you what that's going to do. On the left-hand side, we have 3 halves, then raised to the 2/3 power. So this is called power rule 2. So power rule 2 comes when you have a power raised to a power, and that rule tells you to multiply the exponents together. So in order to simplify the left-hand side here, we need to take that 3 halves and we need to multiply it by the 2/3. So that's how that simplification works. And when we multiply this, 3 cancels with 3, 2 cancels with 2, leaving us with a 1. So this completely cancels out, leaving us with x minus 3 on the left-hand side. So that looks a lot nicer there. On the right-hand side, taking 27 and raising it to the 2/3 power, that is the same thing as taking the cube root of 27 and then squaring it. So that's how the 2/3 work. The 3 is the index, the 2 is the power of this. So in order to simplify that, the first thing we need to do is take the cube root of 27. The cube root of 27 is 3. 3 times 3 times 3 does give us 27. And then after that, we need to go ahead and square it. So 3 squared, 3 times 3 is equal to 9. Which you can see here changes this to a one-step equation left to solve. All we have to do is add that 3 to both sides, giving us that x is equal to 12 there. Okay, so take the reciprocal of that fraction, raise both sides of the equation by it, but you need to make sure that you understand how to simplify that. So on the left-hand side, it's typically just using that reciprocal, using that power rule. On the right-hand side, you've got to remember that rule on what a fraction exponent means. Remember, the denominator is always the index. The denominator was 3, so that's a cube root. Had it been 4, I would have done the 4th root of it. And then you raise it to the power of the numerator is how that rule there works. So we got x is equal to 12. So let's see then if we can take example B then and do the same thing with it. So remember example B, we do have one additional step in the beginning that we need to work with here, because our first step is to isolate your term with your fractional exponent by itself on one side. And it's almost by itself, we just need to move this 7 over. So the first thing we're going to do is we're going to plus 7 on both sides, giving us x squared minus x minus 9 to the 3/4 is equal to 27 then. So your next step after that is to take the reciprocal of the fraction and raise both sides of the equation by it. So here our fraction is 3/4. If we flip that fraction around, we get 4/3. So that is what we are going to use as our exponent. We are going to raise both sides of the equation by 4/3. On the left-hand side, remember that gives us power to a power. 3/4 raised to the 4/3. That means we take 3/4 times 4/3. But if you take any number and multiply it by its reciprocal, it's always going to cancel out to 1, which is why we do this. So it cancels out to 1 and leaving us with a much simpler expression to solve. So that just completely gets rid of the power on the left-hand side. On the right-hand side, 3 is our denominator, so that means we are taking the cube root of 27 and then we are raising it to the numerator, which is a 4. So we just talked about this problem, or very similar to it. The cube root of 27 is 3, since 3 times 3 times 3 is 27. And then the next thing we're going to have to do is take 3, raise it to the 4th power. So 3 to the 4th power, 3 times 3 times 3 times 3 is actually equal to 81. Okay, and let's just go ahead and keep dropping down that left-hand side there. So with this problem here, we are left with a trinomial on the left-hand side set equal to 81. So since I see that this is still a quadratic equation, this is still, we have an x squared term in it, that means we can't just continue solving it the regular way of solving equations. With a quadratic equation, you want to move everything over to one side of the equation so that you can try and see, can you factor it, do we need to use the quadratic formula, or what else is going on with this one here. So the first thing I'm going to do is move everything over to the left-hand side of our equation so that all of this is set equal to 0. So that gives us x squared minus x minus 90 when we combine all of that together. So I'm going to go ahead and move this up so we have room to work with here. So when you have a quadratic equation, always start by checking to see if you can factor it. I think that that's the easiest way to solve a quadratic equation if it's factorable. If it's not factorable, then we can see what else we need to do in order to solve this. Alright, so after we subtracted that 81 to the other side, we're left with x squared minus x minus 90. So let's go ahead and factor this trinomial. So we are factoring the trinomial with the leading coefficient of a 1. So you always look at that first term. Remember, these first spots in the parentheses are what multiply to get that x squared. The only way to multiply and get x squared is x times x. Then we look at the 90 and we think what two factors can multiply to get 90 but can add or subtract to get our middle term. Our middle term is a 1. Okay, so we're looking for what two numbers multiply to get 90 but add or subtract to get 1. So there's a lot of things that multiply to get 90. 1 times 90, 2 times 45, 3 times 30. Let's see, 5 goes in there 18 times, 6 goes in there 15 times, 7 doesn't go in, 8 doesn't go in, 9 goes in there 10 times. Okay, so these are your factors of 90. We are looking for what multiplies to get 90 but adds or subtracts together to get 1. The only combination of that that works is the 9 and the 10. 9 times 10 is 90. 10 minus 9 is a 1. If you need to do some refreshers on factoring, please search up the factoring videos and rewatch those if you need help with that. Otherwise, 9 and 10 are the factors we are going to use for this problem here. And again, keep in mind the rule when it comes to your signs. Whatever sign the middle term has, the bigger number has to have it. Because the middle term is negative, that means this bigger number of a 10 must also be negative. But then you look at your back term here. If your back term is positive, that means these have to have the same sign. If your back term is negative, these have to have different signs. Our back term is negative, which means we must have different signs. And since the 10 is negative, that means the 9 has to be positive. So it factors to x plus 9, x minus 10. So again, just check your work real quick. X times x is x squared. 9 times 10 is 90. 9 plus negative 10 is a negative 1. After this, we use the zero factor property to continue solving this problem. The zero factor property says to split each one of your equations up, set them each equal to 0, and solve. These are both one-step equations, so for our first equation, we subtract 9 on both sides to solve that one, to get x is equal to negative 9. The right equation, we add 10 to both sides to get x is equal to 10. So we're going to have two solutions for this problem. We get x is equal to a negative 9 and x is equal to 10. So a little bit more work involved to do example B, but essentially the process was the same. Isolate your fractional exponent, raise it to the reciprocal, and then work on simplifying that using your algebra skills there. Otherwise, that's it for this video.